Okay, welcome everyone to this event, which we called MQTT Dynamic MQTT Mapping, or we also said it in MQTT Mapping Extension in the invitation. Today I have Christoph Strack with me. Christoph is a senior solution architect for IoT in the DACH region for Software AG. Together we present today a component we have developed together, mainly Christoph, which allows you to dynamically map MQTT data format to the Cumulocity data format domain model. We will split the session in two parts. The first part will be covered by myself, which is mainly the concept part. The second part, which is the exciting part, to give you a live demo and present the things we have developed, is Christoph's part. Some housekeeping rules. I think you already have recognized, I disabled all the cameras and mics for you, only for Christoph and myself. I enabled them. Later on in the Q&A session, I will enable them. I will also enable my camera now. You can actually see me. Also, if you have any questions to the slides we're presenting or the demo we have, just write them down in the chat or write them down for yourself and ask them later in the Q&A session. I think we are set to go. So first of all, I wanted to start with a little bit commercial from my side, because as you know, I'm the ecosystem manager for IoT developers. I cannot say enough that we have a lot of resources, which are actually basically three. I want to mention again, it's on the left side, the developer portal. So if you have a developer and you are the first time joining this kind of event, it's a very good portal where you get all the content which you might need as a developer, like trainings, documentations, open source examples. They're all linked to the developer portal. If you're not already part of the IoT tech community, I honestly would be very thankful for you if you join them, because we have a very, very active and growing community there. We offer very excellent articles about Cumulocity IoT and other IoT stuff. So if you're not part of this community already, please join. And the last one on the right side, of course, the IoT developer event series. We have done some events in the past already. This is another event we have today. In future, and I think in November, it's already scheduled but not organized yet. There will be another event for this event series. This will cover the topic how we build analytics builder blocks. Yeah. So if you also have any ideas what can be covered in this kind of developer event series, just reach out to me and send me a suggestion. That's more like the commercial part. Now let's get back to the original topic. Let's get started with the concept phase. Most likely, if you want to connect a device to Cumulocity, we talk about agents. And the agent I define in the following way. The agent for Cumulocity, first of all, needs to retrieve data from a physical device or some interface. Then you need to map the data to Cumulocity domain model we're providing from the platform. And of course, you need to securely and reliably transport this information to the platform by an IP protocol. That's a very abstract way to define the agent. And this is also, of course, valid for an MQTT agent. When we come to the standard of what Cumulocity is currently offering, is that we have, on the one side, we have an MQTT endpoint, which allows unlimited functionality in regards of what kind of topics can be sent, what kind of data format can be sent. And most likely, if we talk about the left side, you see all the devices, we need a device agent, which actually is doing the retrieval, mapping, and transport to the MQTT endpoint already on the device. Yeah, so we talk about device agent doing all the mapping, transport to the Cumulocity data format, and supporting, of course, our protocol Smart REST or JSON via MQTT. We have a limitation in regards of devices which are actually closed. So when the device sends some data in a proprietary topic structure or any other data model we are not supporting, it's actually not working for the Cumulocity endpoint. And this kind of use case or this kind of option, I want to address together with Christoph today. I want to give you a solution how you can actually do that, how I can connect the device, not sending the domain model, smart REST or JSON directly from the device, but sending anything differently, and how I can shift the agent from the device agent to a server-side agent and do this in a zero-code approach. Yeah, as I said, the limitations we currently have is we with the endpoint is we focusing on smart REST and JSON data model only. The device itself, when it comes with a pre-built agent not supporting Cumulocity, then of course it has a topic structure and comes with data model which are not supported. And most of all, you must then extend the device agent on the device. And this is not always possible because I call them the closed MQTT devices. In some circumstances, especially if you're not a device partner or device provider or the manufacturer, you don't have access to the device. You cannot make any changes to the firmware or add any software to the device. And that makes it very difficult to actually connect the device to Cumulocity IoT if this is closed and sending some proprietary data and topic structure. So this is actually the problem we wanted to address. It is more like an historical thing of what we did in 2020. I started to think about this because I had a use case of a customer coming to me, approaching me. Yeah, I have now closed devices, sending some generic data in a generic topic structure, how I can connect it in a generic way to Cumulocity IoT. So this was the first thing I came up with, this kind of architecture. On the left side, as we only have the MQTT endpoint in Cumulocity IoT, we need a generic MQTT broker. And what I just did is just used Mosquito, used any existing high MQTT broker out there in the market. They're open source, they're also commercial, you can use it right away. So this is the first thing what we need. This is not part of the component we demonstrate today. It's more like the use them then. And then I came up with an idea. Yeah, okay, now I have the MQTT broker and the data in the MQTT broker, but now how I can map the data to Cumulocity IoT domain model, I came up with a microservice idea and saying I don't want to implement a microservice, which is now here a server-side agent, like call it so. I don't want to implement each time for each kind of different device type a new microservice. Let's come up with a microservice idea that makes it a little bit more dynamically. Yeah? So I came up with a microservice structure which can be extended with so-called data mapper callbacks, where you can implement your own callback or handler and then forward the data to Cumulocity IoT. But this also has some drawbacks, of course. The microservice that can be extended by the callbacks and handler is already fine, but this is hard-coded. So you need to be a developer, of course, and you have to hard-code the mapping logic in that microservice. And if you change any kind of for any data mapping, you have to build and redeploy the microservice. Yeah? So this is some kind of a drawback. Also, which was not there, like how I can connect to the MQTT broker. There was an application properties file I used to specify the MQTT broker details like user details and a URL and port, but this is also not very flexible in that way. So as a summary, I said, okay, it's kind of flexible, but not flexible enough. The one microservice to rule them all is nice, but yeah, it's not the finest thing I can think about. Yeah, so just forget that. And maybe start with a new idea, how we can actually do that. And then Christoph and myself, we get in a discussion because we had another customer approaching us with the same requirement. I have MQTT devices sending some data, how I can do the data parsing with Cumulocity IoT. So Christoph and myself started brainstorming. And this is mainly the results of our brainstorming. And we asked ourselves, what if we use the generic MQTT agent, the microservice, and extend it in the following way? Let's make some assumptions. First assumption is, yeah, it should be mainly for POC or solution approach. Yeah, we want to make sure that you can easily and fast integrate closed MQTT devices to Cumulocity IoT. That's the main focus. And let's get back to our experience. What do you think? What is the data model which is most likely sent to Cumulocity and via an MQTT broker? And we recognize for ourselves, in 90% for us, it was JSON. So let's focus on JSON first. So these are the general assumptions. The other ones I don't want to go in detail because of lack of time. But from the usability perspective, we said, okay, the handler approach is a good one, but it can be much more extended. What if we have something like the Cloud Fieldbus or Node-RED graphical mapping capabilities? I think it can be done. Let's build some graphical mapping capabilities that we can actually drag and drop or somehow have on the left side something like the source data model, on the right side the Cumulocity data model, and then just map the data. That would be really nice. And let's do this in a zero code approach. So actually that we do not have any files and then we need to deploy it to a microservice, but that I can actually do this without being a developer. That would be really nice from a usability perspective. And additional features, we said, okay, when it comes to data mapping, because we are also often told, yeah, data mapping is very complex, it's a very tough story, but it's actually not so complex if you make some assumptions and if you want to focus on a few things. But what is actually needed is you need to make expressions. Yeah, and with expressions, I mean, yeah, arithmetic and string functions, for example. Make a substring, take an object out of an array, calculate some values, numerical values with some arithmetic functionality and so on. This is mainly as expression language. So it would be really nice if we can reuse an expression language and build this in the mapping engine. That would be really nice. Yeah, so these are the main things I wanted to highlight we focus on. And we said, yeah, we agreed on this, let's do this. And then we actually started development. And the development, we first of all make sure that we had an architecture. And it's very similar to the other one from the generic agent, but we made a lot of extensions in the microservice itself because the focus of the microservice changed. Again, still we have the external MQTT broker. This is still the case. We're still relying on that. But for the microservice in the middle, the blue box, we now have the MQTT client. We also have this another one. But now we don't have handler or callbacks, but we have a data mapper where we can actually process data in a dynamic way. And also to allowing them from a UI, we provide endpoints to manage the mappings, we call it, that you can create a mapping, delete the mapping, change a mapping, do other stuff like message snooping, and so on and so on. So we provided REST endpoints for front end, and also provided a front end in Cumulocity as a plugin, which we can use in an administration UI, where you then have an MQTT tab and then actually can do all the mapping on a graphical way like we wanted to have it. So this is the architecture we came up with, and then we started developing and trying to test with the data we had from our past opportunities with JSON format and tested all the things. So we get in a very complex thing like how we do the device handling and so on, but Christoph will also mention this in a little bit more. This is just for your reference. I just explained all the components already. Maybe one thing I wanted to highlight is that in the data mapper component, we implemented the expression language. As we have the assumption that we focus on JSON first, as the first data format, we have an expression language called JSON Data, which is really impressive, and we can also see later on. But all the other ones I already have mentioned, and it's just for reference. Also, I wanted to mention that this approach, what we did, is not addressing the whole thing like that we want to extend the external MQTT broker. But as you might know, there's a feature in the backlog of Cumulocity IoT, which is called generic MQTT. And this is a very high-level architecture of how it will look like in the product itself. But you might have recognized that we don't need the external broker anymore on the left side. But right now, as part of Cumulocity IoT product, we have now a generic MQTT service, which can actually handle the topic, generic topic and payload very dynamically, and can then use a messaging engine, and we can connect to the messaging engine and adapt our dynamic MQTT mapper to actually then do the same again. Yeah, so this is more like a future outlook how this will look like in an upcoming release 10.17 and 10.18. So this is currently planned to be available then. Also, what is asked very often, with that change, we also will support MQTT 5. And the generic MQTT does not interfere with what we have developed as a dynamic MQTT mapper, because the data mapping is not part of that feature in the first release. It's only providing MQTT endpoints where you can actually connect devices and having generic topic structure and generic data formats. And then the mapping to the Cumulocity data format is still a custom thing. And here we can come again with our dynamic MQTT mapper to help that. So what we actually planned, and we have aligned with the product management about that, we will adapt once we have the MQTT, generic MQTT is available, we will adapt the dynamic data mapper to the generic MQTT feature. This is actually currently planned. So this is all for my part. And now I hand over to you, Christoph, to give a live demo about what I just explained on a concept and high theoretical level.
Hello, everyone. Thank you very much for the introduction, Stefan. So my name is Christoph Strack, and I'm happy to introduce this in a live demo. So I will start. I will take you on a, first of all, probably I have to share my screen. Just a second. So I hope you can see my screen now.
Christoph.
Okay, perfect. So I will take you, we will all go on a bus ride across Europe, starting from Berlin. And we will see how it works as we drive along. So what is all of this about? So I work with a potential customer. So it's a European operator of buses, and they have a telemetry system. And we would like to connect their telemetry system over MQTT to our Cumulocity system, to give them some insight when buses start, what happens to their buses, and everything. So for this, I have equipped our demo tenant here with this additional feature, which is called MQTT Mapping. So once you explore yourself the GitHub project, we can take a look at this later. And you deploy the two components. You deploy the web UI and the microservice. You will see here under the administration settings and MQTT mapping, you will see this additional component. And this additional component is the web UI to define your mappings. So here only a brief look at the configuration, nothing so important. You just give the connection details to the MQTT broker of our potential customer, and then you are ready to start. So our broker is connected, and we can get started. So what I have in mind now, I will go over three different use cases. So first of all, before we can work with our potential bus, starting somewhere from Berlin and going down all the way to Italy, where the weather is a little nicer, we have to create a managed object for it. So we will use the company's source format, which is in JSON. And then we will define a mapping and we will see how to identify properties on the left side in the target and map them to the right side, left side in the source and map them to the target. And we will see how we bring together the customers' IDs, external IDs to internal IDs. And in the second part of every run, I will send an actual payload. So the customer bought a new bus, it needs to be onboarded, and then the mapping is applied. The JSON payload is sent across. It's listened to by our microservice, by our solution, and then the mapping is applied. So here we still see the values that we entered at design type, but then at runtime they are substituted for the actual values from the left side. And what happens is a new managed object is created, and in this process a new external ID is created, because later on, for example, if we send events or measurements to it, we need to refer to this managed object by its external ID. So let's take a look at how all of this works. So here I start in this mapping editor and give it the new. I will explain a little bit more about these fields when we added a mapping. Then it makes a lot more sense. So here you see the wizard popping up, and it brings you through 3 steps. So you define your topic, you define the templates and the substitutions, and in the end you can test it and see if everything is fine. And once everything is fine, then you can deploy it or send it off to the microservice, and then it listens on our new buses. So let's get started. So here we have a concept of subscription topic and template topic. So the subscription topic is actually the topic that is used in an MQTT subscription. And we came up with this idea in order to reduce the number of subscription topics and use a second concept, the template topic. So in order to specify further, if you use a wildcard expression, how you would like to apply it, how you would like to apply your mapping to. So here I use So here I use a wildcard topic. This is already recognized by the solution. It tells you, okay, this is a wildcard topic. Now you need to give me some additional information. So you see here, you are not ready. You cannot continue here. So you have to give me the information. How should I identify your bus? And this is by clicking through and marking the device identifier here in this topic structure. Now this is fine, but we want to work with the inventory, and so I select the inventory here. You can the quality of service and so on, and here I can switch on and off. I want to work with it immediately, so I set it to active. And here comes in this point, because our potential customer doesn't use our internal ID identifier, so we have to map it from the external identifier to the internal identifier by the use of an external ID. And here you can specify an external ID type. I use the standard, and then we can continue to the next step. So here we see the main part of this wizard. We have to define the templates, so the source template and the target template, as well as the substitution that at runtime brings this across then at runtime. You see that the payload is here already. Something is added to the payload. So on the left side, the wizard cannot guess what we should use here for the left side. But there is an additional feature. If we have time, I come to it. We can snoop for templates, and so listen for them, and then use them in the setup here. I will explain it later on. So here I will, but this is something that was added because we need to have a representation of the identifier. So this is added by the wizard because we are using a wildcard template. So now we need to use this this identifier to work with our identity. So before I continue mapping, I have to patch the payload. I switch here from the tree mode to the code mode, and then I take I've prepared here some JSON payload and add it here. And so we see later on at runtime that something changes. I just use here dummy, and then I switch over here to the tree mode, and now we are almost ready. You see here on the left side we have the capacity. We would like to add our bus with capacity. So we see in the inventory what it is like, and now we have completed the first step. So we have defined the payload on the left side, on the right side. Now we can start to work with the substitutions. So one substitution is generated out of the box automatically because we work with wildcard topics. So this is already auto-generated. So the next step is we would like to map our capacity from the left side to the right side. So you see, as soon as you mark something down here, these are the two, the left side and the right side, that will make up your substitution once you add it. But we do not want to add the device identifier. We want to add the capacity. And as soon as you pick something here, the capacity is resolved by using this this JSON Data. JSON Data is a standard. It's quite powerful, and it works in most ways. It works straight or very intuitively to identify simple properties, but you can extend it by using even functions. So you can do arithmetic stuff, or you can work with timestamps, do conversions or whatever. So it's quite powerful. And the really nice thing is it works in our web UI as well as in our backend in our Java, which is written in Java. So now we have identified this, and I would like to map this. So this is added here. This works two-way, and you can see what happens. The same could or will work when you work with arrays, or even with deeper structures. So there is no limit in identifying this. So we have mapped this. The next step is I would like to identify the type. I take this one, and it's a third one. So there's some valuation built in. For example, if I were to click here and map it a second time, an editor or a warning will pop up. Do you really want to override your existing mapping? No, I don't want. I want this. What I really want to do is I want to map my name, and the name I take it here from the operator, and now I start adding some expression. Oh, it should be like this. And give it an ampersand, and we add the line to it. Is this correct? Oh, that looks quite nice. So additionally, I click on here, and now we are ready. So this completes the second step. I continue. Second. So I continue to here, and here we can see what it would look like and run a test, transform test, and I'm ready to send it off. It works. It's confirmed, and here we see what it would like in runtime. So if I confirm it, now the mapping is already activated. And this can be seen here in this table. So here, the blinking green lights, they show I deployed a mapping, it's active. You can deactivate a mapping for certain reasons, but let's let it active. And then it's tested. So I have run a test iteration. So that gives an entry to do some qualification or to start a process if you only allow mappings to be brought or used if they have been tested. And the last slide, which we do not use at the moment, is the snooping. So that is coming then later on at the end. So now we are ready to onboard our first bus. For this, I will connect with my MQTT client, and I will send off a bus, add a bus. Sorry, I have to check. I think I deviated here from the, yeah, it's, I didn't. So let's correct it here. So to follow my script. So this is updated, and now I send off my payload to Express. It's an Express bus. And now since I listen, move it a little bit to the right. Since I listen here,
you have a typo, Chris. Express.
Thank you very much. Thank you very much. Good. So also
double slash, sorry. Double slash Sweden Express.
Yeah. Thank you. So the MQTT topic is listening to this. So it will catch this message, but this is not sufficient. So we need to qualify it further by helping our mapping to add the template topic to identify which topic it is. So we could have as well standard buses or express buses or whatsoever, which might have a different mapping, require a different mapping. So this gives you a far better way to work with this. So now I add here my payload. And so it should have, it's a larger bus. So let's take it 90, the capacity, and we don't go all the way to Rome. We go to Milano. And now we are ready. We post it off. So our payload is sent just to make sure. And let's see what happens here. So the first step could be here in our monitoring. So we deployed the mapping. The mapping has received one message and it didn't raise an error. So if I go now to the device side, to the device management and refresh here, I would expect that we see a new bus. So here's our Eurobus starting from Berlin and goes all the way to Milan. And this was just registered now. So this completes our first see what happens here. This completes our first use case where we created a managed object in the inventory using a mapping and defining our mapping so that it comes across. So in the next use case, this follows exactly the same pattern. In this case, we want to map an event. So something happens to our bus, it stops at a petrol station, and we define a mapping. So this is taken from the customer's JSON payload to the Cumulocity standard payload. And what we have to do is we have to define the usage of the external ID. And then at runtime, the mapping is applied. And what happens is that the external ID is resolved by external ID Berlin _01 at runtime. And the other properties are as well then resolved, and an event is created. Okay, let's see this in action. So I go back here to our mapping editor and start all over again. Add here a new mapping. Use again a wildcard editor. So here this time we want to use an event. I map again the device identifier. I use the previously defined serial number, and here it doesn't allow me to continue because I have not selected the device identifier, because the mapping doesn't know, okay, which identifies your device. Is it the first level, the second level, or somewhere further down in the template name, in the topic name. So now I continue. You see here on the right side, that is a nice part. So it recognizes which API you work with and gives you a very simple suggestion what your payload could look like. Here on the left side, I do not know how it looks like, so I have to apply a little work. And just a second. So here I add the payload. So it does some basic validation if it is a valid JSON payload, and we see now here that we have our device identifier. It's already mapped here to the right side, and at runtime, remember, it's resolved by using an external ID, so we don't have to take care of this. Then we have the event. We map it to the right side, and we map the text. What happens here? We map it as well. So now we are almost done. What you could do here as well on the right side is to use any timestamp from the payload. So there is sufficient support to use this JSON data expressions and convert your timestamp from whatever format and bring it to the ISO timestamp format, which Cumulocity uses. So I will not use any of this data in the payload because it's outdated. So what I will use is I will use a function which is called now, and you see it returns the time in ISO format, and this can be mapped here to the right side to our timestamp here in our event. So let's review if everything is fine. We mapped the device identifier, the message type is mapped, the text is mapped. Remember, here you can add any string functions or whatsoever, and we set the timestamp to now. Now I continue here. We can do a transform, see what it looks like, and now we deployed it. Let's turn our attention now that the bus actually stops. And the telemetry system sends across this information. So I take here the message. And here we go. I delete this because this is it's not needed anymore. The bus stopped, let's say, twice. Let's say it was yesterday, and remove this. So this is now ready. I just check if I took the correct, yeah, it looks fine. So now I connect, and I send it off. So it was sent off, and let's see what happens. I take a look here, refresh in our monitoring if something already. So that is interesting. There's some error. We have, and the mapping was, the message was received, but an error was indicated. So now I have to check. Actually, in the log of the microservice, what happens. I leave this for the time being. Let's see if I find the error immediately. Let's see. Message type is correct. No, I don't see it. So let's give it a very short brief try if something. What happened here? Maybe I made a typo in. So it says the ID was not found. Something did not work here when mapping the external mapping the external ID. Okay, I picked the wrong external ID. So let's give it a second try. So send it off and see if we have more luck this time. Yeah. So this time the message is received. It's processed correctly. No error has occurred. And let's see what happened to our bus. And we will see here. Here is our message. All of this happened because I I deviated here from the script, so didn't use Berlin 01. Express is the external ID. That's why it works now. Okay, this I take a look at the time. So we still have some time to go through the last scenario where we will use a measurement. So it's the same process. So we take the payload from the source, transform it to the target payload by defining a mapping. So we identify how we use the external ID. So this is resolved. And then at runtime, we apply the defined mapping, and the mapping then resolves this ID using the external ID and replaces it with the internal ID, and this results in the end then by creating a new measurement. So let's get started. I come back here to the mapping editor. I add a new mapping and I take and this time, yeah, this one here. And let's say we have different things we would track from the bus. So this time it's the gasoline, and we have to identify how we find our identifier. We take a measurement and take this one here. Then we continue on the next part. We patch our payload here on the left side. And add it here. So, and here on the right side, we do the same. Do a few corrections, so it's not a temperature payload. It's for tank, and it's liter, and the rest can be done by the mapping. So again, this device identifier is already mapped to the source, so we don't need to take care for this. And here, let's map our measurement again. The measurement, if you do some calculations or things like this, you can apply here arithmetic expressions and do whatever you like. So here we go. We have mapped it, and now we need to take care of the time. For the time, I do again this now. Now, and it resolves correctly, and we map it. So let's check if we did the correct thing. So we mapped the identifier, we mapped the fuel, and we mapped the time. So now everything should be fine. And we take a look at how it looks like if we were to run it, and we set it off, and it's deployed. So now we continue, and this time we do a measurement, and I have to use now the external ID express, and here comes our measurement. So here we go, and let's make it a little more. So the timestamp can be taken out. And now we are ready to refill our tank. So it was sent here from the client, which is fine. I switch over to here, refresh. Takes a little time. Yeah, everything should be fine. So let's take a short look at the log file. Low resolution error. I think I took the wrong.
Felix said there's few missing in the topic, but I guess because we are lacking of time, we have now 10 minutes.
Okay.
I think the message is clear. I think if you do this live, things like that happen.
Yeah. Maybe one last iteration. If you want to do use this Snoop, and then you can you can start all over here again, and then you enable this. Now it takes a different tour. It informs you that you started snooping, and you want to first listen to some source templates in order to work with them. And if you continue like this, your message, your mapping is deployed, but it listens for snooping. It listens for templates, and once it has recorded some templates, you can enter the wizard again and use these templates and work with these. I think that is a nice feature as well that helps a lot to be more efficient when you define these mappings.
And you actually don't know what to expect in coming via MQTT.
Yeah.
Okay, thank you very much, Christoph. Let me share my screen again. And let's come to the conclusion. First thing here, then I have to turn off my camera again. PowerPoint presentation, here we are. You can see the PowerPoint presentation, I guess? Yes? Oh?
Yes, I can see it.
Perfect. So this is actually the mapping. Let's come to the conclusion. So what we have seen now is how the MQTT mapper can help to connect closed MQTT devices by dynamically do JSON-based mapping to the Cumulocity IoT domain model in a fast manner. Yeah? So like Christoph just said, if you don't know what to expect, just connect to any MQTT broker, do the snooping, explore what is coming in a JSON format, and then do the mapping based on that. And I think it's a couple of minutes to map. You don't have to program any line of code. So this is a zero code approach, what we try to achieve. And I think we are already there. But what is still not 100% implemented, of course, is all the cases that can happen. I think one we have discussed already in the chat, that you also have some things that in the topic structure you want to map to the payload as well. We are really looking for that kind of feedback. Yeah, if you can provide us any kind of JSON data or topic structure you are experienced from devices, share it with us. Or even if you're happy to, if you're looking forward to use that, we're also looking forward for your contribution, of course, because this is an open source component. You can have a look on it and how we can adapt it in a way that we can support the most use cases we can think of using JSON. So we are really happy to if you approach us and for your contribution. What is actually planned for the next steps? I think Christoph and myself, we have now invested, I think 4 weeks since we have started this project. So we discussed a lot of things like the device ID handling and so on and so on. We have so many things still in our heads and how we want to continue. One thing we have still on our in our heads, which is on top on the list, is how we can support not only server side the approach, but also the side like having gateway agents like the Synedge.io, because we also have some kinds of devices where we have a local MQTT broker, where we also have the same issue that we need to map the data, maybe not only on the server to code the domain model, but maybe on the SYN edge to the domain model. So it would be really nice if we can take that mapping and deploy it to the SYN edge and actually execute it on the SYN edge as we did on the Cumulocity IoT. Yeah, so this is something we have in mind. We have prepared it already with the operations, so we can send an operation with a mapping to the SYN edge, and then the SYN edge, of course, needs some kind of runtime to execute the mapping and adapt it a little bit and so on. Again, we are looking forward for your feedback so we can enhance the mapping cases. So if you have anything, get in contact with us. And of course, once we have the details, how the generic MQTT feature will look like and what are the interfaces to connect to the generic MQTT feature of Cumulocity IoT, we will then adapt the MQTT mapper as well. So we can use it with the pre-built feature of Cumulocity. So that's everything we have from our side. We have now 5 minutes left for Q&A. Let me open the mics for you. Just give me a few seconds. Hello, mics. Now, if you want to speak up, you can. Christoph, I already have a question for you, I guess. I think there was a question if we use the library for the JSON editor in the front end.
Yes, this is it's mentioned on the website as well. Maybe if you go to the GitHub project in the documentation, so it's a JSON Data editor, JSON Data library that is used. And for the JSON editor, it's JSON editor something, but it's mentioned as well in the package.json. So it's quite a powerful editor that can be used and customized.
Okay, if you want to find out the details, we can send it to you, but also you can have a look on the GitHub project. There's a component called MQTT Mapping, and then you see the package JSON there. You can find it yourself if you want to look into it.
Yeah, for example, what is possible with this Angular component is that you register a schema. So to do this is something I didn't cover. So you can register a schema and make sure you don't miss a required property when you send off payloads to Cumulocity.
Are there any other questions you want to ask us? There was a question if there's a REST API. I think I answered it already in the chat. Yes, we have a REST API defined because we're also using it from the front end plugin.
Stefan, is there any support here? Is there any other programming language support? So obviously you've done everything in Java so far. Is it sufficiently extensible that you could maybe plug in other languages, or is it just Java?
It's just Java. So what is the use case for plugging in other languages
if somebody is not a Java developer?
Okay.
God forbid.
Yeah. Sorry. Yeah. This is so. This is only currently the project only works if you extend it by using Java. So if you want to use Python or something like this, it would need some considerable rework. So, but there could be an idea that you write, for example, your extension or part of this the service in some other language, and it plugs in or works together then with the core part. So that is possible. Sure. I would say.
Sure. Thanks.
There's a question by Kevin. Any comment on the non-functional aspects, throughput, per tenant microservice, tenant isolation, what kind of size? Do you want to answer it, or should I cover that?
Sorry, can you repeat it?
The question from Kevin is, are we considered any non-functional aspects? So it's throughput, how big must the microservice be sized? What is the tenant isolation level we selected? Is it per tenant or multi-tenant?
So it's so for the isolation level, it's single tenant. So we looked into making multi-tenant using multi-tenancy. That could be an extension. So for the consummation, I have not done any tests, performance tests. So that's something that is outstanding.
That's why we said we start with the POC and solution approach. We want to get it started, and it's just, I think we started it 4 weeks or something. Yeah, it's a pretty new component. Since we have developed it, we are on a pretty early phase here. So we are on that phase also that when it comes to be used in any kind of production system, this is a totally different story, of course. Yeah, and then we need to think about all this stuff. Is there a customer already using this already? Kai is asking that. No, as I said, it's an early phase. This is the first thing we promoting this component.
You're also going.
It's an exhibition. A lot of people.
Sorry, can you mute yourself? Yes. No, but we are looking forward to use it in customer demos and any kind you. If you want to show it, we can help you supporting it to set up a demo so you can actually present it to a customer.
So one aspect I pointed out on the GitHub page as well is so this library parsing and evaluating this expression for JSON data is different in the front end and the back end. So that and the level of support for JSON data, it's a standard is different. So if you plan to use something very elaborate and advanced, it should be tested. But for the use cases I used, it worked very good.
Okay, we're already 2 minutes over time. Thank you very much, Christoph. I really know that this was tough because of your medical situation, but I think it was a very good giving insight of what we have developed. Again, if you have any feedback or want to have a demo for a customer, just approach us and then we can find a meeting and a date and then we can go on this. Thank you very much for your participation and for your feedback. Looking forward for you attending one of the next events. See you guys.
Thank you. Goodbye.